All right, so welcome to the workshop. The way it's laid out is we are going to do a Zoom session today for about an hour and 15 minutes. We're going to do a deep dive into the create performance task. Up the link to join. There you go. We're going to do a deep dive into the create performance task. We'll talk about the mistakes that your students might run into, how to use AI properly for it, and how to use AI to improve their create performance tasks, okay? We're going to review a lot during the time, and then you guys have the choice to actually get 5 PD hours and complete some work. So what you will get access to, if you're not a UTeach teacher, is you will get access to our create task module, and I'll walk you through it. We have a module that takes you through the entire create performance task in 18 50-minute lessons, okay? From start to finish, they'll do everything. They'll get it uploaded into the digital portfolio. So what I'm going to review with you today is the beginning, and that's what you see here. It's the intro and planning phases. And in our curriculum, those would be assignments CT 1, 2, and 3, okay? Then we have assignments 4, 5, and 6, and 7, and that's when the kids actually do their programming for the create performance task and upload it into the digital portfolio. I will review these assignments with you, but if you want to get 5 PD hours, you just have to complete assignments 4, 5, 6, and 7. And we do Scratch and Python in our curriculum. So I gave you both of the modules here, but you only have to do one programming language, either Scratch or Python. And that's only if you want those 5 hours, okay? If not, just hang out with me today, learn a lot, and then be on your way to facilitate this to your students, in a really good way so that they get all the points necessary. All right, and then at the very bottom, you'll get access to our sample materials. You'll have access to everything we do here as PDFs. So even though you can't put your students onto our platform, you can at least go back and use everything we did here today. And then at the very bottom, I threw in UTeach's new AI assignments. We have a module. You guys can check that out on your own. So let's get going here. Thank you for joining me on a Saturday morning. So the first thing we're going to do is we are going to review the Chief Reader Report. So let me just move my face over here. There we go. All right, and the first assignment, okay? So the first thing you need to realize is we need to talk about the Chief Reader Report, okay? Every single year we get a Chief Reader Report. It lets us know how the students did on the exam and where they ran into issues, all right? And the first thing I always like to do is back up just a little bit, okay? And let's just talk about the exam in general, right? I'm glad you guys are here with me this morning because here is the breakdown of the scores on the exam, okay? And the reason I like sharing this with teachers is because you should share this with your administration, okay? You can see right here, students need a 3, 4, or 5 to pass the exam. But yet, if you look down here, okay, we have almost 39% of the kids, okay, who don't pass, okay? So we have 21 and 16, that's 37. And then now, you guys, some of you are probably math teachers. So that's a really large portion of the kids who don't pass. But the other thing that is really interesting is look at the average score. The average score is a 2.86, which means the average score isn't passing, right? So people just think we're going to put kids in AP classes and they're all going to pass in the end, and that's not what happens. But the good news is look at the average score. It's 2.86, which means if you can learn a little bit more about the exam and teach your students a little bit more about the mistakes, about the trouble pits that they might hit, they won't have those issues and they'll do a little bit better. Never before has a little bit better meant more on an exam than this exam. A little bit better is the difference between a 2.86 failing and a 3.0 passing. So what I always like to say to my teachers is that your students who get 5s are going to get 5s with or without you. All right. Your ego can take a little bit of a blow. You're not going to have any impact on those kids. All right. And the ones are going to get 1s with or without you. What you're really here like with me on a Saturday morning, is so we can push these kids who get twos into that three group, that we can keep the three in the three group solidly. And then maybe we can even push some of those fours to fives. Okay, so this is what you're up against. Okay, this is one of the fastest growing courses in College Board. 176,000 kids took the test. Okay, so what mistakes are the kids making? Okay, so let's move on to the next page. Okay, so we are going to go step by step here and break down how the kids did on each point on the scoring rubric for the create performance task. All right, and I want you just to take a look. I broke it down on the left side of the screen, so it's a little like, reader friendly, user friendly, but on the right side is the actual chief reader report. Okay, and the chief reader report this year, they released two. One for set one questions and one for set two questions. Okay. They have different sets of questions they give the kids, but each question is similar and testing the same thing. Okay. Now, the other thing I want to tell you is the failure rate, okay, has increased slightly over the past 3 years. Meaning, since AI has been introduced and allowed on the exam, kids have failed more. All right. And you'll figure that out right now when we talk about the written response. Okay. College Board does not care if they use AI to build their program, they're encouraging it. Okay. And the reason is because on testing day, they have to go in and answer written response questions with nothing more than just their PPR, their personal project reference sheet that they uploaded to the digital portfolio. And all that is a picture of their procedure and their list. Okay. So where are they struggling? Where are they kicking butt? Okay. Well, the kicking butt part is that video. Okay. The students have to make a video and it has to show their program running. It has to show the input. It has to show the output. All right. If the program needs to do two different things, it has to show the two different things the program can do. Here's where College Board is pretty cool. The two things a program can do can be not working and working. Okay. So the example I'm going to keep coming back to over the next hour is, let's say I make a temperature analysis program. And I type in temperature values into this program, and then it collects it into a list, and we can do different things with those values. We can take the average temperature over the course of a certain number of days. We could pick out the highest temperature, the lowest temperature, whatever it is. Okay. Now, that means in order for the program to work, I would have to put in a temperature value. So like when I'm making my video, if I want to, I can type in, and one thing I can type in is 79.6 degrees. And then it'll show the program saying, thank you for entering that temperature value. And then what would you like to do next? But let's say I put in the word dog. What's supposed to happen if I put in the word dog? Nothing, because it's not a temperature value. So if your students just show putting in the word dog and the program not working properly, that's okay. Now, as a teacher, you would probably want the program to say like something like, hey, you're supposed to put in an integer or a number value or something like that. But College Board doesn't even care if the two things that the program needs to do can be working and not working. All right. And the reason I'm telling you this is because it's not required, but I have been a reader for the AP exam numerous times. And I will tell you, whatever they are going to write about should be what the video shows. Okay. 177,000 kids take this test. Okay. I'm going to tell you how to become an AP reader in just a minute. People who grade this have to grade like 1,500 create tasks over the course of a week. If everything lines up nicely, it's easier for the person to grade it. Your student will get a higher grade on the exam. Okay. And also, we never see the code. The person reading the exam, grading it, never sees the program code. All they do is watch the video, look at the PPR, and read the written responses. The only time we go to the PDF of the program code is if there is like something wrong with the PPR, or there's something wrong where we can't see it because it's a corrupt image. So yeah, that's how the grade is. That's how it's graded. So it's important for it to be consistent. So in my video, I would show me putting in 78.4 degrees and the word dog and watching what happens down both of those, plays out. So This is the one part of the exam where the students do really good. Out of the 1 point, they get 0.94 average. All right, that's a big win for them. The only thing that the video cannot do is it cannot have any voice narration. They can use closed, they can have subtitles, but they can't do voice narration. And the other thing is it can't have any personal stuff. So, like if they go to John Smith High School, it can't say they go to John Smith High School. Believe it or not, you might be the teacher at John Smith. There's 177,000 kids taking the exam. What's the chance your kid's test is going to pop up in front of you? And it does. All right. So, those are the only two things to remember for that part. Okay. Now, the program. What does it need to require? Okay. The program needs to have, and it's pretty easy, it needs to have input and output. And we're going to do a deep dive into this in 1 second. But it needs to have a procedure that they can pass a parameter through, and that's important. They got to pass something through it. Underneath that procedure, they have to have sequence selection and iteration, not where it's being called, but in the actual procedure itself. And then they need to have a list. The list needs to be integral to the functioning of the program. So what does that mean? It means they need to use the list in their program. So my example with the temperature analysis program, right? I'm collecting the values in a list because I need to. I'm going to go back and use all of those values to either figure out an average or to figure out the greatest value, right? If your student made a game and in the beginning of the game, it just said, what is your name? And you typed in Jason. But then it did nothing with that list. It just collected the names and then went off and just played the game. They would get 0 points for that list. It has nothing to do with their program functioning. It's just information they're collecting. Okay? So the students are good at making sure their program has a procedure that passes a parameter, even if it doesn't work properly. They know it needs a list, okay? And they know that the procedure needs to pass the parameter and it has to have sequence selection and iteration. So they don't do too poorly on that part either, okay? And then the next part they do really good on is explaining how the program works. What's the purpose? What's the function? Okay? What's the purpose of Facebook? Well, the original purpose of Facebook was to bring people together, right? To share your wherever you are and just have some fun. But how does it function? It functions by taking in videos, pictures, taking in your location, monetizing your personal information for their profit. So how it functions and what the purpose is are two different things. And that's what the students talk about in that third point. So you could see right there, you got the first 3 points out of the 6 on the scoring rubric. Students do well on, okay? They can make a video. They know what the program requires, okay? And they can explain the purpose and function. Now, the reason they do good on these parts too is because think about it. They're going to use AI, which is encouraged by College Board, to develop their program. Okay, and I'm going to talk about that in detail in a little bit. But the written response, these next 3 questions, these are all the ones they have to answer on testing day. And these are really difficult questions, okay? The questions are designed to be incredibly difficult so that students who just use AI to do the program, but then don't go back and study the program, understand how it works, use AI to explain the program to them in a detail that they'll be able to explain it. That's why they fall off a cliff here, okay? The identifying Boolean logic and the lists, those are both kind of the issue. We're going to talk about test cases. That's on you guys, the teachers. But these two, the students need to actually learn about the program so that they can tell the reader who's grading it, how could you write this program differently if you didn't use the list? Like if you didn't use a list, what would the code look like? So they would have to then say, well, if I didn't use a list, I would probably have to have like an if-else statement for every single thing I'm putting in, which would mean I'd have to have a lot more code, which would mean I'd have a better chance of having a bug. All right. And same thing for like the procedure that passes the parameter through it. Okay. So they actually, that one would be like, how does the procedure manage the complexity of the program? All right. And they would have to say, well, like if I didn't have this procedure that passes the parameter through it, I would either have to repetitively ask a question, and then for each question, I get an answer and have to assign it to a variable. And then, so like, and like, I don't expect your students to be able to answer these two questions. Even with how good of a teacher you are, they really need to use AI to explain the code to them. And that's what our assignment CT7 does. Our assignment CT7, we'll talk about that. You do with your students a couple weeks before the exam, and it takes their original responses, their general responses, and makes them into super responses that they would get the point for. Okay? Now, the testing one, errors in testing. This is on the teachers, okay? Test cases are just whatever the parameters you're going to use to pass through the procedure to demonstrate your program working and not working. So like, as I've been using the same example over and over again, I'm going to make a temperature analysis program. My test cases are going to be 79.4 degrees and the word dog. Because when I type in those two test cases, they each demonstrate a different thing that the program is doing. So the common question I get from teachers is like, well, does that mean these test cases has to be hardwired into my program? Not really, right? Like I'm not putting anywhere in my program that if they put in dog, specifically the word dog, it's not going to work, right? But I am going to put somewhere in the program that it needs to be a number or an integer. All right. So, you know, that could be, you know, for me, no, it doesn't have to be hardwired into it. Now, let's say I make a bridal registry program where you can go in as the bride and put in what you want people to get you, or you can go in as the guest and see the list of what everyone got. Well, maybe in that situation, you might have to hardwire in, not the test cases, but like how to get to the path you want to. But then the test cases would be like, hey, I want a dinner set. I want a couch. I want money for a honeymoon. All right. Those would be the test cases to show the program doing different things. So when kids are struggling on the test case part of this, they really shouldn't. This should just be the two things they put into the video to show their program doing two different things. All right. So I hope that clears it up for people because, you know, 0.57, and it got better last year. I think the previous year was like 0.43. And it's because the College Board did a bad job of explaining test cases to teachers. So that's why I'm explaining it to you this way. Okay. Because teachers panic. Well, I have to hardwire it into my code. Not necessarily. All right. So those are the 6 parts of the scoring rubric. And you can see where the kids are excelling and where the kids are struggling. Okay. So what are the top 5 mistakes? Okay. What are the 5 mistakes the kids make? So here's what I want you to realize. Okay. When you're grading this, kids whose programs don't work, well, they're like, well, maybe I can just make a video of it kind of working or not working and then talk in the end like it did work. And I'll fool the reader who's grading it. So that doesn't work. Okay. We call it the ghost input and the ghost output. Okay. And that is what the student shows in the video is never actually in the code anywhere. Okay. Right. Others show rabbits moving, but in the code, there's no visible way the user started it. So we just like to know that, like, and I said this before, whatever they're showing in the video is what they should be talking about in the written response. Keep it consistent, make it so that the person who's grading it can just whoop right through. What I'm watching is what I'm reading about, and then that's what they're discussing on the written response. Okay, number 2, I just told you about the test cases. Teachers need to do a better job of teaching the test cases to their students. It's not intimidating. When we talk about the little things of going from 2.86 to a passing of a 3, this is a perfect example of it. Because I will show you in a minute the difference between a 3 and a 4 on the create task, what it means for them down the line, passing wise. It's a huge difference. All right. Mixing up the question and the answer. Okay. Yeah, I guess like that one, you just want to make sure that the student knows what the Boolean expression is supposed to be doing. Okay. And I just want to move through this a little quicker here. Um, Logic errors versus syntax errors. And then I already talked about this, the trivial list. Okay, the list needs to be important to the program. So what I did was I reviewed this first one with you. In here on your own time, you can review the second set, and it's pretty much the same thing. It doesn't matter which set of questions the students get. They do really good on the first three questions. They struggle on the last three. And this is a better example of how they struggle. You see, test cases is getting better, but these two questions here, the list and the procedure, they're designed for students to get them wrong unless they know what they're talking about. All right. And I know Dr. Jeff Gray from the University of Alabama gets mad when I tell people this. I'm friends with him. He makes up the procedure question, passing the parameter through it. And every year when the test comes back, he's like, dude, 12,000 kids got my question wrong. I'm so excited because they want to keep the integrity of the exam high in an AI era. And they've managed to do that. And they're proud of themselves because they're making a written response without AI hard to prove that the kids know the information. All right, so I also go in here, the 5 details. Okay, so, and then I have a takeaway list of everything from the reader report that you can review on your own time. I just want to move on because I have so much more to talk about. All right. Hey, if you really want to learn how to teach the create performance task, the best thing to do is go become an AP reader. Okay? 177,000 kids take this test. They need people to grade it. They'll take you. You can grade it remotely. You don't even have to go to Kansas City, Missouri. You can grade 1 or 2 create tasks, or you can grade 1,000 of them. It's up to you. You get paid more the more you grade. More important, they will train you and norm you to grade it. It's an hour-and-a-half PD. When you get out of that PD, you'll be able to do what I'm doing now. You'll be able to literally be able to teach your students the ins and out of the exams because they train you how to grade it. So if you got nothing to do in the month of July, click on that link there, start the process, become an AP reader. All right. And they don't pay me anything to do that. I haven't graded the exam in a few years. They don't let me now that I work at UT. Sometimes they do if they really need people, but they would rather have teachers do it. Okay. So that is where we wanted to start. Now, what does it mean? Very quickly, let's go inside the numbers. I remember when I was a kid, we used to do this for football. Okay. So if they get this score on the create task, here's how many points they need to get on the rest of the exam. So the reason I bring this up is because we have a multiple choice test that's incredibly difficult. Students literally have about 2 minutes or less to answer each question. And for some kids, it literally will take that long to answer. And by the way, I will be sending the recording out of this to everybody afterwards when we're done. So if you have to hop out and go do your Saturday morning, no hard feelings, I totally understand. So you can see right here, I always say your students should get at least a 3 out of 6 if you're doing your job in the classroom, because you just saw there are 3 easily attainable points for them to get: the video, what the program should have, and talking about the purpose and function. And if they can do that, they can get a 3, which means they get 15 out of the 30 points, which means when they go in for the multiple choice test, they have to get about 25 to 35 questions right. And I know that's a big 10 question shift, but the problem is it's not the same every year. They take the average of the scoring, so it can shift very slightly from year to year. So just say this, 30, it's right in the middle. If your students get a 3, they got to get 30 right here. That's hard. Okay, 30 is hard. I'm not going to sugarcoat it. It's a hard exam. It's hard enough just to get through and read every single question. But if you can teach them the test cases right? If you can just teach them the test cases, now they're looking at a 4. Okay, if you can get your students the 4, their whole life becomes way easier on testing day. On testing day now, they are only going to probably have to get 25 right. Now, the reason I say this is big is because On the multiple choice, if you've taught this before, you know there's this reading passage, and then there's 5 questions attached to the reading passage. And the reading passage are the easiest 5 questions on the exam. It's a layup. They read a paragraph about some map app that takes their data and their privacy, and they have to answer 5 questions about it. So, like, those are the easy 5 questions. So now, if they can get the 4, that 25 really just goes, can they answer 20 questions on the exam? So that's why we're here. Every little bit counts. Teach test cases a little better, and then the 3 becomes the 4, and life becomes so much easier. So once again, a lot of good information there to look into on your own time. Okay. So now we are going to discuss 2 things. We're going to dive into AI, how to use it properly on the exam, how your students should use it to make better programs, and then how to use it to make really good written responses. But I want to back up a little bit too. So in our curriculum, we use Scratch and then we go to Python. Okay. Now, I love Scratch. It's actually fun. Okay. And I don't see why students can't just still have fun when they do this. But AI is really good at Python. So for some reason, okay, all the kids like to do their programs in Python. And I like to say when they do it in Python, they're going to wind up doing it backwards. They're going to tell AI to write a Python program for them that has a list, a procedure that passes a parameter that has input and output. They're going to, have the AI write it. And then AI is going to write it. And then the student is going to have to study the code in order to learn about it. So it's kind of backwards. They're asking AI to build the house, and then they're going to learn all about the house. Well, it's so funny. AI can do tremendous things. It can't do Scratch. It can't do block-based programming. Okay? But what I'm about to show you is it can actually become like the R2D2 co-pilot we really want AI to be, and work with your students to improve their Scratch program so that they're really doing it the way they should be. They're building the program, they're building the house alongside Scratch, alongside AI. And then they know how to answer the questions. So I just want to show you this because I was doing a workshop in Harmony ISD out in Texas, and someone asked me, hey, how can AI do Scratch? Can Gemini Scratch? Can, ChatGPT Scratch? And I could not believe it. They couldn't do it. But here's what I was able to do. Now, your students, and let me clear this up for you right away. Your students can use previous assignments for their create performance task. They have to add new functionality to it. That's the rule. And what they discuss has to be that new functionality. So what I was able to do was, and I just talked about it right over here, this was one of the first Scratch assignments I think I ever made. It was hysterical. I was in a workshop back like 15 years ago. And I made this really basic program. And it was like if you're staying at a hotel and you need to get a lounge chair by the pool, for some reason, you got to wake up at like 5 a.m. at some of these resorts to get a chair by the pool. So I made this app where you can actually click on the lounge chair and reserve it for either the full day or the half a day and type in your room number. Now, it's a fun program, but it's not a create performance task. There was no procedure. All I'm doing is fancy broadcasting signals with some input, with some music. But what your students can do is they can take this Scratch program, okay, save it as an SB3 file because that's the format, and then they can upload it into AI. And they can say, hey, I'm uploading a Scratch project. How can I turn this into a perfect score on the create performance task? What would I have to do in order to make sure I have a list, a procedure that passes a parameter, input and output? And then can you explain it to me like I'm a 7th grader because I'm new to programming? And that's what I did in this assignment. And I'm sharing it with you here. So it took my basic program. And then after I uploaded it, it started to tell me what I need to do differently to the program. Okay. And I can then go step by step and say, hey, can you break this down in more detail for me? So if you still are like me and you're like, hey, like, I don't care if you know Python, I think you should use Scratch on the create task. But block-based coding still has a place in the coding world. As a matter of fact, I just got done developing a middle school curriculum for us, and I go from scratch to vibe coding because who needs to be bothered with the syntax of Python these days? They need to know how to write a program, and Scratch does that really well, teaches them all about program design. All right, so just something to think about, okay? Scratch, AI, all right, might be one way to go, okay? So this is one thing that you can use AI for, okay? And it's totally cool with College Board to develop and improve on a program they already used. But let's go deeper. So most of your students are going to want to just use Python because most of y'all doing Python anyway. So this would be like how I would use AI to develop a create performance task. And let me first start off by saying this. The create performance task should not be the pinnacle of their programming for the entire year. Let me say that again. I know it sounds weird, right? Like, it's just going to be a program that has a list, a procedure that passes parameters through it. Okay, like input, output, it's going to be basic. And I'm going to share the different programs that are the most likely to get a perfect score for your students. Notice at no point in the last two sentences that I just said did I say they should be making the second coming of The Legend of Zelda or the next generation of Mario Kart. That is not what the purpose of the create performance task is. It is literally a way to demonstrate to somebody that they know how to build a basic program. So like in your class, you might want to give them like a Python final exam project. That's fine. Google Python final exam project, 10th grade, and get a rubric. But that's not what this is about. That's not what this is supposed to be about. So let's just go into this. This in detail talks about how your students need to cite that they used AI so that they don't get nailed for plagiarism. Plagiarism happens when they do not cite that they used AI, not when they do use AI. So College Board allows you to use generative AI tools, okay? They need to understand that they can only use it on the program development. The video and the written response has to be done completely on their own, okay? So we hope that they use AI to generate ideas. They are going to just use it to do their code crafting and debugging. That's fine too. But what they don't do is explaining practice. They need, and we're going to go through this, they need to ask questions like, hey, can you explain why you used this procedure? And if you didn't use this procedure, how would I have to write the code differently? And then your student has to go back and study that answer and memorize it. And on testing day, they need to spit it out, right? That's what they need to do. So the golden rule, okay? Even though the AI is going to develop the code, you'll see in this assignment, we are going to go back and forth with it. We're going to get to it so that we get what we want. And then later on, you'll see in assignment CT7, we will literally take their basic answers and make them into the ones we want them to memorize for the exam. All right. So here's how you acknowledge AI right here. Copy this, paste it, tell your students to put it right in their program. When they do a written response question, all right, in the very first question, they just might want to paste this in. We're going to talk about this. They can't have any code comments on the PPR. That's the pictures they're submitting to the digital portfolio. That can have no comments, okay? Because that they're going to get printed out and handed on testing day to use to answer their written response questions. So they cannot have any comments on that. But on the PDF of their code, their entire program, they can have code comments, right? That's good practice. And when they answer the first question on the testing day, they should say something like this. I leverage generative AI tools to help design the initial structure for my program. If it was the whole program, they just say the whole program. If it was just the loop, they say the loop. But then they say, I thoroughly reviewed it, modified it, integrated all AI-assisted code to ensure it aligned with my project's purpose and that I completely understood its function for the AP exam explanations. Okay. That is a beautiful cover there, but whole response, they won't get in trouble. Okay, so make sure you use that type of response. And then I give you a little AI checklist right there. All right. So your students would literally open up ChatGPT or I like Gemini. I think Gemini's better. Open up Gemini, and they're going to have to come up with a create performance task. So now, what does a create performance task have to include? Here it is: input output, a list or collection type, a student developed procedure that has at least one parameter, sequence selection and iteration, and is called somewhere. And you're also going to have to submit a video, the PPR, and we'll talk about the PPR. It sounds scary. It's not. And then they're going to have to answer a written response. And you got to give them 9 hours of class time to do all this. Okay? So, what are some create task ideas? A number guessing game will get them a perfect score. A quiz game that asks 5 questions, but then tracks the answers in a list. That is okay. Like a to-do list manager, contact book, temperature converter. Hey, how about that? Voting system, alarm clock. I'm going to talk more about an alarm clock because it's a simple program, right? But if we want to, we can have an alarm clock that has alarms that go off. And just like your iPhone, it has to put all those alarm times in a list. And that list is then integral to the functioning of an alarm program. All right? So you want to make sure that when you say to ChatGPT, you want to say, I need you to design a program and just copy all this into it. You need to create a program that has this in it. And then it's going to produce something that is way too advanced for your students. And that's when you then have to do this. You have to say, hey, I need a list that's meaningful, a procedure that passes a parameter, and oh yeah, by the way, code that's easy for a 10th grader to explain. Oh, and can you put a lot of comments in my code so I know what it's doing? All right. But remember, those comments can't be in the PPR. All right. And that's what the AI is going to do. Okay. It's going to take a program and it's going to do that all for them. All right. So let me go over here to the next page. So here we go. So here is, and this is just if you teach Python, this is how we do Python in our course. Everything is built into our platform. We just type in the top right corner and click the blue run code button, and then our program runs. All right, so I just wanted to share this with you. If you just want to do some Python coding and check out our platform, you could do it right here. But let's actually try it out here. So here is a Python program that you can use. All right, it's an alarm clock program. Okay, let me just come up here and I can just copy the whole program, come up here, delete and paste it in, and then I can just run my program. Okay, oops, run code. All right, you can see it says, welcome to the alarm clock, type set to set a new alarm, set, enter the alarm time, let's say 1200 hours. Alarm set for 12 o'clock. Type set to set a new alarm or start to begin clicking alarms. It's checking alarms. All right, so now you can see here, if I type in set, it does one thing. If I type in start, it does another thing. All right, but then look at what I did. I asked the AI to start giving me explanations and start with the list. What does the list do? This list holds each alarm time that the user sets. Okay? Then it has to do it, checking the alarm. What is the purpose of the program? What is the parameter? Well, is a parameter, it accepts alarms. So then what is the procedure doing? It will explain to your students everything they need to know for the written response part of the create performance task. Okay? It's okay for them to work with it. Be able to lay it out. Question first, you teach when you use code.org. Will I be able to lay it out like your examples? Yeah, I mean, if you can lay it out, you'll also have access to everything I'm showing you as PDFs. So if you want to, you can just print out our create test modules assignments and give it to them as PDFs, and then just use whatever platform you're using. So you can make it work. So you'll see here, we are basically using AI to tell us everything we need to know for the written response part. And that's what College Board wants you to do. They don't want you to do this on testing day, because that's what all the kids did the first year. They let the kids use AI. The kids answered the written response portion when they submitted their digital portfolio, which meant they had access to AI. They all cheated answering their questions. The following year, they moved the written response to testing day on a lockdown browser where they can't access any AI. And that's why you see the difference in the scores. And now they kind of nailed how to do this and keep the integrity. So that's just something I wanted to show you, how the students can use AI as their co-pilot. Okay. And then what I was talking about, and I'm just going to touch on this because our assignment CT7 does this in detail, but you need to then take your program and specifically ask AI, would I get a point on the scoring rubric for AP CSP for this response? And when you blatantly tell AI that type of prompt, it'll tell them what to do. Okay. So like here, I basically show you what the initial input was and then what the output was that got the point. So like here for point 3, they're talking about data abstractions, the no point trap. I have a list called inventory. It stores sword, shield, and potion. When the user clicks the bag, it prints the list. I can't say this enough. Printing a list is going to get them 0 points. Say that again. They have to have the list do something integral to the program. If all they're doing is printing out the contents, that's not it. So look at what a actual sample response is. I use the list named enemy positions. Instead of creating 50 separate variables for every enemy, this manages all of them. My algorithm uses a for each loop to check every coordinate in the list against the player's location. This allows the program to handle any number of enemies dynamically without the list. The code would be hundreds of lines of repetitive if statements. That is why they get the list question wrong and the procedure question wrong. They need to be able to come up with a response like that. So that's what we want to use AI for. We want them to first write this, but then after AI shows them the good thing, that's how they're learning. Okay. And we actually do that in assignment CT7. Okay. Let's see. How gray area is it? All right. So once again, the gray area is if they use the sample code, they need to add some sort of new functionality to it. Like you just said, slightly modified, and that's what they need to talk about. Okay. And also a little bit about the gray area as well. If you're teaching this to 10 kids in Montana, right? Like, come on. The only one who knows your students are building upon a program you gave them is you. And you're the one who checks off on the end. So like if you think your student added enough functionality and you're good with it, then check it off as complete, final, complete in the digital portfolio. But if you are teaching this using code.org and your student is copying a code.org program and not adding any functionality to it, code.org has what? Like 100,000 of the 177,000 kids using it. So the graders are going to be aware of that. They're going to mark it as plagiarism right away. All right. So yeah, you just got to make sure that with the AI examples that your students are adding some new functionality to it. Yeah, I mean, true to College Board ethics, that's all. College Board ethics is take a project they previously used, add some new functionality to it. It could be the list, right? They could have had a program that had those 100 if-else statements. Now they're adding the list. All right, great question though. All right, I am reading the chat box, so if you have any questions, let me know. So that's what I do in this assignment. I just want to keep trucking along here, okay? And I give them the master prompts. Okay. Like have them answer the question and then ask AI specifically. Hey, here's my video I just made. They uploaded into Gemini. Based on the 2025 AP-CSP rubric, does my written response clearly distinguish between purpose and function? Right? So then they paste in their answer. And then it'll basically say to them, like, review my video description. Do I talk about input and output? And then more importantly, I am using a list named this. Does my explanation clearly show how this list manages complexity? And if not, how should I write it? So please don't be afraid to have your students dive right in and use AI as the R2D2 of answering create task problems. Okay? So, one last thing I will touch on. All right? When I say touch on, I mean briefly. There are a lot of vibe coding platforms out there right now, like Google AI Studio and other things. Okay? Keep your students away from them. Okay? Have your students not use them to design their code. Now, all these AI studios are just basically ChatGPT and Gemini in a different box. Okay? And they want to try to give them more opportunities. Hey, you want to build this program? And now let me build it for you. And I'm going to do it in 100 lines of code. And then you can talk to me and correct it. Stay away from them. The vibe coding is not for the create performance task. Now, if they want to take their program and put it in a vibe coding platform and ask it those questions that I just talked about, will this get me the point on it? Yeah, it'll do that, but it'll do that in the normal AI anyway, whichever one you're using. So stay away from these platforms, okay? In the CED for the AP CSP exam, there is a page. I think it's like page 220 or something like that. It says all the acceptable programming languages for the exam. It's got like 25 languages there. So if a kid comes up to you with a weird question like, hey, can I use Google AI Studio to do it? Just check the CED and go look on that page. And if it's not listed there, no. If it's listed there, yes. Because we do get gray areas, right? The kids love like the Minecraft coding platform. And I actually do think they accept that now, but in the past they didn't. All right. So make sure you check that out. All right. So what we're going to do now is I want to show you guys, if you're a UTeach teacher, here's how we tell you to do the create performance task. And in your curriculum, you have access to the create task module. Now, if you aren't a UTeach teacher, I want to make sure you have access to this. So you will have access to this workshop to the end of the school year. So feel free to project to your classroom what I'm showing you. You will have a PDF version of this, so you can just print them out, have your students do this on whatever platform you're using. But here's how we do it. Okay, so we set it up into 7 assignments. Okay, and our curriculum is designed around 50-minute class periods. And you need to give your students 9 hours of in-class time to do the actual coding of the program. Okay, so what does that mean? In our curriculum, we actually do CT 1, 2, and 3 with the students. I'm going to talk about that in a minute. We show them everything that's expected of them. We review samples with them. We get a general plan together with them. And then we give them 9 hours of class time on their own. And we are quiet because of that gray area that someone just mentioned. We do not help them while they do assignments 4, 5, and 6 on their own. Assignment CT4, they will actually write their program. CT5, they'll get their first chance to do basic written response answers. And then CT6, they'll upload what they need to upload to the digital portfolio. And then CT7, that they do 2 weeks before the exam in May. That's when they'll get the chance to take their basic written response questions that they did in CT5 and using those AI prompts I just showed you, turn them into super answers in assignment CT7 so they'll get those points. Okay? So that's how it's laid out. That's what I'm going to review with you in the next 23 minutes. Okay? So let's take a look. CT 1, 2, and 3. We're going to do that together just like you would do it with your students. And then just like I gave you the opportunity, your students would choose either Python or Scratch if you were in our curriculum, and they would then do 4, 5, and 6, or 4, 1, 5, 1, and 6, 1 if they're doing Python. All right, and then they come back to 7 on exam day. So let's review 1, 2, and 3. So CT1. CT1 is going to take you like 2 class periods to review with your students. What we did was we took all the important information from the CED and pulled it out and put it in this assignment because who wants to read the CED, right? All right, so we put everything here. So the first thing we talk to your students about is the digital portfolio and what they're going to need to upload to the digital portfolio. Okay. The digital portfolio is where they are going to upload 2 things. They're going to upload a picture of their procedure that calls the parameter and where it's called in the program. And then they're going to take a picture of their list. And they're also going to take a picture of where it's called in the program. And they upload these images to the digital portfolio. Please put a star next to this, an explanation point. These images can have no comments on them whatsoever. Okay? What happens is on testing day, when the students need to answer the written response questions, they will get a printed version of this. They call it PPR, the Personalized Project Reference Sheet. It is a picture of their code snippets. Okay? That is all they get on testing day to answer their written response questions. So the reason there's no code comments allowed on there is because they consider that cheating. Because even if the code comment just says like this is the input, it does not matter. There are kids who in the past have literally put cheat sheets in there and used it to cheat on the rest of the exam. So your testing coordinator at your school, your AP coordinator, on testing day, they're going to print out every kid's PPR and give them a paper copy of it. And they are instructed if there is any code comments on anybody's paper to throw it away, and that student does not get to even answer any questions about the written response. They'll get a 0 out of 6. So please, that's on you as the teacher. If that happens to any of your students, it's your fault. Okay, College Board did a really bad job of telling teachers about it the first year. I had a lot of teachers who felt terrible afterwards because their kids did. I mean, we tell them, put comments in your code, but not on this particular part of it. Okay, so that they'll need to upload to the digital portfolio. And then the other thing they'll upload to the digital portfolio is a separate PDF of their entire program code. Now, on that program code, you could have code comments. It's up to you. But let me explain something to you. And I said it earlier. The person who grades this will never see that PDF of the program code. That is just a safety net in case the digital portfolio blows up on the student and we can't get anything out. The grader at least has the original code to look at. But they will never look at it 99.9% of the time. Video, written response, we grade it. Okay? So that's what the digital portfolio is. You will go in there after your students upload everything and you give it a final rubber stamp. You look to make sure your students uploaded the correct thing and you say, good. Now, here's the hard part. If your students uploaded the wrong thing, you can't specifically say, hey, Betty Lou, you uploaded the wrong thing. But someone talked about the gray area. You can go into the gray area and just say to your class at the start of class, hey guys, group announcement. Make sure you're uploading the right stuff that you're supposed to be uploading in the digital portfolio. Make sure it is the proper code snippets, the procedure that passes the parameter, and the list. That's okay. You can't specifically tell Betty Lou, even if Betty Lou is the only person who did it. So please live in the gray area, massage the gray area, all right? But don't violate the gray area, okay? Because you don't want to say Betty Lou. Hey, Betty Lou, somebody will then call College Board on you and say, hey, our teacher helps Betty Lou, but nobody else. All right, next part of this assignment, we review with the students. What's required? Okay, and we've talked about this. You have to submit a program. You got to do a video of the program running, and you need to do a PPR. You need to upload the stuff to the digital portfolio. And notice over here, just like in the game of life with the little stick figures in the car, final program code can be developed by more than one stick figure. And a stick figure includes AI. So wherever it says student developed procedure or something like that, Even though it says student developed, they mean AI. But video, they need to do it on their own. Code segments, PPR, on their own. Okay, next, what does the program contain? It needs to have an input. It needs to have a list. It needs to have a procedure that passes a parameter. It has to have sequence selection and iteration in that procedure. It has to call your procedure. It has to have output. You need to make a video. Okay, you need to upload a digital portfolio, personal project reference sheet. And yeah, this is what they upload. A picture of the list and where it's called, and a picture of the procedure and where it's called. Actually, I had that backwards. This one first is the procedure.
Hey, Jason, can I interrupt you for 1 second?
Yeah, go ahead, Pete.
On these questions that you're asking here, they change every year. It's about what's the box is describing it, but the question that they can ask is very different. How do we know what to focus in on to answer each of these 4 questions with the PPR?
So with the, you just go back and look at the sample set that they shared in the chief reader report. They do share at least one set of the questions, and you're right, they switch them every year. They're all testing them on the same type of thing. All right, so the topic, Pete, is going to be the same, generally the same. But if you go back up here when we were doing this first thing, cracking the code, up here, you'll actually find the sample questions in the actual chief reader reports, okay? So just go back up there and you can find those. All right, another good question by Pete. Thank you, Pete. By the way, I worked at the University of Texas for 8 years, but I'm a lifelong New Yorker, so feel free to interrupt me. I talk a lot. All right. All right. So this assignment here, though, okay? This is, like I said, we're going to review with the students, and then we review the scoring rubric with them. Okay. We literally show them, here's the scoring rubric. Okay. It's out of 6 points. Your first point is going to be for your video. Then does your program have everything it needs? But the reason we review this is because it's an all or nothing game. They have to do everything on the scoring criteria or they get a 0. So if the video shows the input and the program functioning, but doesn't show the output, they don't get the point. If their program has a list and a procedure and it has sequence selection and iteration, but their procedure doesn't pass a parameter, doesn't let you pass anything through it, they will not get the credit for that. So I like to review this with them because they need to understand that it's an all or nothing game. It's not like, I know how to do purpose. I kind of know how to do function, but I can fudge my way through it. There's no fudging. All right. This is a fudge-free test. Okay. So this is why I review it with them. And I explain to them, just like I did with you, man, out of 6 points, we really need a 3. And if you can get to the 4, 5, or 6, your life is going to be so much better on testing day. Okay. So we continue. Okay. Actually, this page is just a line for you. This is something I think you might want to print out for your students to have. So you are not allowed to help them once they start assignment CT4. Once they get to CT4, it's cut the umbilical cord, 9 hours of their own time to finish the create test. They have 9 hours to do 4, 5, and 6. They can't ask you any questions during that time. Hey, what's a procedure? What am I supposed to do? What type of list am I supposed to use? What does purpose mean, right? They're going to have anxiety. The brain farts are going to be off the charts. Simple things, they're going to panic and forget. What we did was we made up a glossary. Now, this is for our curriculum. We use Scratch and Python, but we literally have here every single definition they might ask you during it and what the definition is. So, hey, I forgot what purpose and function means. Here's what purpose means. Here's what function means. Okay. I'm using Scratch. What are examples of input again? Remember, input is like when we ask a question or if we hit a button or something like that. And here's what it looks like in Python. And we did this for everything. We explain, okay, here's what output looks like in Scratch, and here's what output would look like in Python. And then remember, data abstraction. We want to use a list. And there's your list blocks, and here's how you'd make a list in Python. And so this is a great thing to have available for your students because Mr. Walker can't answer any questions, But Mr. Walker can give them this, and then they don't have to ask Mr. Walker. They just ask this. So this is another one of those gray area things where we can't help our students if they ask us, but why do they need to ask us? They can read it. And we just have this simple thing. And you guys, like, hey, remember, did you use the right procedure? Is it the one that has a spot to pass a parameter through it? Because if you don't have a place to pass anything through, you're using the wrong procedure and you're going to get 0 points. So that's one thing that we need to remember. And that's why this assignment takes, a couple of days to go through. Okay. So this is our first assignment, CT1. All right. Then we have assignment CT2. Now, CT2 are all the review samples that College Board has released. We actually have already updated our curriculum for next year with the new ones that they put out. And that's what I have right underneath this assignment is the review samples from 2025. All right. And I'm not going to go through this with you because there's so many here, but all you need to do really is in here, click on pages up here in the corner. Here's every single review sample, good, bad, and indifferent, right? We give you 2 exemplars right over here. UTeach sample create task in Scratch. UTeach sample create task in Python. Okay, and these are perfect scores. The programs are right built into here. It's a contact list program. Here's a perfect video. And then we give you what the PPR looked like. And okay, here's the program code. So we give you everything here. Okay. So you could use this, but then we have also ones by College Board. So here's more questions, just more information. Remember, your students should see negative exemplars as well as positive ones, so they know what pitfalls not to fall into. So here we included, we have another assignment for you to review with the students. Here's the most updated one. And then we have this planning document, okay? And in this planning document, the good thing about using our Codio platform and being one of our licensed teachers is you can see what your students are doing at any time just by opening up assignment 4 and seeing where they're at. You'll be able to see if they're doing it incorrectly, if they've even started the program yet, if they're just messing around and not taking it seriously. But we also want to make sure we have a little plan so we know they're following a plan. So what we do is before we get started, we have our students pair up together. And first they fill out this page, which says, I'm going to collaborate with Betty Lou or Gemini or, Copilot, whatever, ChatGPT. They tell us what language they're going to use. What's the purpose of their program? What's the input going to look like? What's the output going to look like? What is their list going to do? What type of procedure are they going to use? And they start brainstorming this out and they start planning out their project. And then they swap with another student in the class. And that student gives them feedback like, hey, this is a great idea. You're definitely using AI because you wouldn't be able to do this on your own. Are you going to you think AI will be able to condense it down to something you could talk about? Maybe do this instead. And they give each other feedback because we do want humans to still talk to one another in this process. Okay. And then after they have some sort of plan, then it's time to drop them into assignment CT4. So here's where you'll say to your students, you're going to do either Python or Scratch, not both. Okay. And then you're going to do your entire assignment in CT4. That's where you do your coding. So let me use Python here. I'll open up assignment CT4. And the reason they do their assignment here is because here's where they'll be able to do their coding. Okay. And it tells them right off the bat, you're only doing Python or Scratch. It tells them when they can work with AI or a person and when they can't. And then when they get to the next page, okay, next, here's where they do their program. And the reason they do their program here, because it's going to be very easy for them to type their code here. We can collapse it down afterwards. We can take an easy screenshot up here. Their program is actually going to be right over here, and we can just right click and download it. So they'll be able to access a PDF version of their code, real simple, and everything can be done here. They can even do, we show them how to do screen recordings. I'll show you in a minute. They can record this corner of their program running. So this is where they'll do all their work. And like I said, if you're a licensed teacher for us, you can just open this assignment up in your gradebook and see what they're doing and give those general class announcements in that gray area. So they do their whole program in here. Next thing they do is open up assignment CT5. Now, most kids are going to want to just go right to the digital portfolio. I'm done with my program. Let's upload the code snippets and let's upload the PDF of my code. But what's really important before that is to just answer some questions about your code. How are they supposed to know what to upload if they don't even know the basics of their code? So what we say right here is, you did this before in assignment CT3. Now that you're done with the program, things have probably changed. You might have added stuff to it. What is now the purpose of your program? What is the functionality of your program now? What is your input and output? Okay. In detail, what is your list doing? What's the name of it? What's the data your list is collecting? How does it manage complexity? You could see it starting to ask them a little more detail. What's your procedure? Where is it called in the algorithm? Hey, what are the two test cases you're putting through that procedure to see the two different things happens? Test cases, procedure calls, all the same thing. Okay? What were the conditions tested? Well, I put in 79.4 degrees to see if my program worked. I typed in dog to see if my program didn't work. What was the result? It asked me, what do I want to enter another temperature value or sort it from highest to lowest? It said dog is not a number. Please enter a number. So this assignment CT5 is really good to do because it starts to get them, all right, I did this program. I got a really good grip on it. Now, let me upload this stuff to the digital portfolio. And that's what they do in assignment CT6. So assignment CT6, oh, cool, perfect timing. We got 5 minutes left here. Assignment CT6, they are going to first submit their whole program code. And guess what? We tell them how to do it. We tell them how to use it using Google Docs, MS Word, all these different things. We show them how to just take screen captures, put it into a Google slide if they have to, because in Scratch, right, it's going to be messy. They got to take a screenshot of every sprite and all the code. And yeah, and then just stick that all into a Google slide, export as a PDF. Okay? So the first thing we show them how to do is how to make a PDF of either their Python code or Scratch code. And then click here, and we show them the instructions to upload it to the digital portfolio. So when they click here, it opens the digital portfolio in a separate tab. They then go into the digital portfolio. They click on create. The instructions are right here. They click on program code. They upload it. They tell you they uploaded it, and they move on to the next step. And the next step is the video. And just like we did before, we have instructions on how to do a video screen recording using Screencast-O-Matic, Screencastify, QuickTime, or Command-Shift-5 if they're using a Mac. So we show them how to do the video. You don't even have to show them how to make the video. And we show them how to do the screen recording, and then same thing. Click here, open up the digital portfolio. All right, upload your video, move on to the next step. Okay, now we're going to upload the code snippets to the PPR. They identify their code snippet for the list. They take a screenshot of their list. They open the digital portfolio up here. They upload their list picture. They then upload where the list was called, and they move on. Okay? And then they do the same thing for the procedure. And then we get to the point where we're done. They've uploaded everything to the digital portfolio. At that point, they're done with the create task. At that point, you as the teacher, you log into the digital portfolio And you will see in the digital portfolio, you have the opportunity to mark everyone's work as final. You get to mark it as this is all done. It is done. They're not going to change it. We're all good. All right. And then you forget about the create task until it's a couple weeks before the exam. And a couple weeks before the exam, you have your students go back in and do assignment CT7. Okay. And what CT7 is we are going to take those previous written responses and make them awesome. So here we're going to talk about program design and function, right? And this is where, now that you've been through my workshop, you should take all those master prompts from the AI module I just did and say to them, put your program design and function into Gemini and say, would I earn the point on the AP CSP create performance task for this written response for this question? And what would your suggestions be to improve it? And this is where the students are going to write down their best written responses that they are literally going to memorize and spit out on testing day. Okay. And that's what they're going to do here for CT7. We take them through the whole thing. And now, Pete asked me earlier, where am I going to find questions from the exam? Hey, Pete, they're in CT7. Right here, we took the 2025 set 1 questions and put them right here for your students to practice answering. Okay, and because we're equal opportunity, here's set 2. So here they'll also get a chance to answer those actual questions. Literally paste these into AI and say, hey, here's my answer for question 2C. Did I get the point? And AI will say, nope, you need to add this to it, or yep, you have an awesome answer. So use the power of the AI. They want them to co-pilot with it, to brainstorm with it. They want AI to be the R2-D2 that helps them blow up the create task Death Star. All right. So what's left? All right. I rarely finish on time. So if you just had fun hanging out with me, learning a lot, you'll have access to this information to the end of the school year. If you want to get 5 PD hours, go do one of these Scratch or Python modules. Do assignment 4.1, 5.1, 6.1, and 7.1 for me, and I'll give you a 5-hour certificate that you can get for PD hours. Now, in here, you will find a couple things. You will get access to our sample materials if you want to try out. We have a cyber course, APCSP and APCSA. If you want to try out our platforms, go right ahead. Everything over here is where you'll find PDFs of what we just did. All right, please ignore the, I copied this workshop over from what I did in February, so please ignore the February 7th up here. But I have 2 versions. I have a version of PDFs that include our teacher lesson plans. That's the teacher version. All our lessons are 50-minute assignments. And then I have a student version, which is just what you guys are looking at, okay, because you guys are students in my workshop. So I do give you PDFs of all this. If you're using code.org, I'm sorry, but next year use us. But this year you can use our PDFs. All right, Pamela's smiling because she uses us and she knows it's easier. All right, but anyway, that's what I have here. And by the way, as an added bonus, I do an AI webinar. One's coming up in the spring, but we do have a 4-module AI assignments that takes you through the story of ChatGPT, how AI works, how to teach your students to use AI ethically, how to build agents. If you would like to print that out and do it with your students, this could be something to do after the exam. I mean, I taught in Brooklyn, New York. We teach till June 28th. Do you know how hard it is to get kids to show up to your class in May or June when Central Park is around the corner? All right. And cutting is a way of life. So yeah, I would need something to do after the exam. Hey, this is a perfect 4 assignments to do after the exam to keep your students interested. So I want to thank you guys for taking a Saturday morning to hang out with me. I will send the recording and everything else I discussed out to everybody. This was a good group, 6 people on a Saturday morning. It was more than I expected. If anybody has any questions, hang out. That's totally fine. I can answer some of them for you. And yeah, thanks, guys. Do well on the create task. Yep. Thanks a lot for joining me.